As with every great thing, Lewis dot structures also have an exception to their normal rule. And so the exception with Lewis dot structures is primarily with how large of how many electrons will each element have, and those are called the reduced or the expanded. There are also things called resonance, and there's beautiful different exceptions to this Lewis dot structure that we just learned in the basic video. So the first one that we're going to focus on is that not every element wants a full octet, and what they do is they want actually what we call a reduced octet, meaning less than 8. The two elements that you absolutely need to know is that boron always wants 6, which means that it'll form 3 bonds, and hydrogen always wants 2, which means it'll form 1 bond. Okay, these are exceptions to the general octet rule, but boron and hydrogen always want these. They do not personally have exceptions. You are going to follow the exact same format, except for the only thing is when you're dealing with, instead of having 8, you're going to make sure that boron only has 6 and hydrogen only has 2. So boron, counting the number of valence electrons, has 3. Chlorine has 7, but we have 3 of them. So total, that is 24 electrons, which means that we have a total of 12 lines we can do. Okay, so I'm going to put boron in the center because it's written first, and typically the least electronegative, which is the central atom, is written first. So then we're going to surround it by my chlorines. Okay, and so I'm going to single bond it, following along on the same steps. So I've used 3. Now I need to, out of my 12 lines. So I'm going to try to make everybody on the outside have an octet. So I've used 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which means that now all my chlorines have their octets, but boron does not. It only has 6 electrons or 3 lines attached to it. Well, in this case, it's actually okay because boron only wants 3, so it's happy in this format. There are also, along with reduced, there are ones that are expanded. And the ones that we're going to talk about are always in the 3rd row or later. And they can actually, because of that D level and the F, they can actually hold more than 8. And so the 4 that we are going to be focusing on is sulfur, arsenic, phosphorus, and xenon. Okay, these can actually hold more than their 8 electrons, so they will have a greater than an octet. And a lot of times what you'll end up doing is placing those extra electrons on the central atom, or sometimes they will bond more than 4 times. So in this case, you're going to still follow the exact same rules. So sulfur has 6 valence electrons. We want to figure out how many total electrons we can have. Sulfur or fluorine has 7, but we have 6 of them. So total, we were talking about 48 electrons, which means I can draw 24 lines. Okay, I'm going to put sulfur in the center, and I'm going to surround it with fluorine. Fluorine is a halogen that is in the 2nd row, and so therefore it can only bond 1 time. So I'm going to then draw the next step where I've made it as symmetric as possible. I'm going to draw my single lines, my single bonds, 6, which means I have 18 more lines that I can draw. So what I'm going to do is I'm going to make all of my octet outside of my fluorine. So I've got 18 more. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I've used up all my electrons. I know that the fluorines, because I filled them up to make their octets, are extremely happy. And if I look at my sulfur, sulfur is an exception to the rule. And so even though it has an expanded octet, meaning more than 8 electrons attached to it, it is absolutely fine because it's in that 3rd row. So it would actually, in this case, because it is 6 lines attached to it, or 6 single bonds, it would be holding 12 electrons. But because, once again, it's in that 3rd row or later, it is absolutely fine doing this. Another one, xenon or XeF2. So we are going to have xenon, which has 8 valence electrons, okay, and we have fluorine, which has 7, but we have 2 of them. So total, that means that we have 22 electrons, which means 11 lines. So I'm going to put xenon in the center. I'm going to surround it by my fluorine symmetrically, single bond them, make my octet of my outside ones happy. So far I've used 8 lines, and now I have 3 more. So 9, 10, 11. Okay. If I look at this, everybody's happy, and xenon is actually happy even though it has an expanded octet because it is past that 3rd row. It is absolutely fine with having its 10 electrons or 5 lines. PCl5. P can hold 5 or it has 5 valence electrons. Cl has 7, but we have 5 of them. So total, that is 40 electrons, which means you're going to have 20 lines you can draw. Okay, so I'm going to put P in the center, and I'm going to surround it with my halogens as symmetrically as possible. It's supposed to be an L. All right, now I'm going to single bond it. 1, 2, 3, 4, 5. I've used 5 out of my 20 lines, so I have 15 more I can use. So I've used 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now all my chlorines are happy. They have octets because they have the 4 lines attached. My phosphorus is absolutely fine with doing this, even though it has 10 electrons because it has 5 bonds. It is perfectly fine with it because it's past the 3rd row, or it's in the 3rd row or lower, and it can therefore have an expanded or greater than an octet. All right, the next thing that we're going to be talking about is charges. So some of these, especially these polyatomics that we've talked about, they have these charges. And typically they're negative in this class, but you can have positive, which we will reference on the next slide. So if you have a negative charge, what you want to do is you add that many electrons to your total number of electrons. I'm going to cross this off. Then what you're going to do is you're going to put them in brackets, your structure, and put the charge outside. So let's figure out how many we're going to need for SO4. So S has 6. Okay, and then oxygen has 4. We have 4 oxygens, so that's 6. But now I have to deal with that -2. So because it's negative, that means I gained 2 electrons, so I'm actually going to add 2 electrons. So when I add up my 6 for my sulfur, my 6 from each oxygen, which I have 4 of, and then I add my 2 extra electrons that I gained from somewhere, I get a total of 32 electrons, which means that I have 16 lines I can draw. Okay, I'm going to put sulfur in the center, and then I'm going to surround it by my oxygens, and then I'm going to single bond it. So 1, 2, 3, 4. So knowing this, I have a total of 12 more lines I can draw, so I'm going to fill out my octets on my oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've used up all of my electrons, and I've used up, and everybody's happy. Sulfur in this case only has 8 for this particular drawing, which we'll learn about. SO4 actually has some other structures that are possible with the -2 charge. And so, but we're going to end it here. I'm going to put brackets around it. I'm going to give its charge of a -2. So this is its structure. With positive charges, all you're going to have to do is you're going to subtract that many from the total electrons. Once again, because it has a charge, you're going to place that structure in your brackets, and then you're going to put this charge outside of it. So in this case, we have NH4 positive, which is the only positive charge one that we'll really deal with in this class. But N has 5 valence electrons. Hydrogen has 1, but we have 4 of them. And then I am going to actually subtract 1 electron because I have that positive 1 charge. So if I add this up, I get a total of 8 valence electrons total, which means that I can have 4 lines. So putting nitrogen in the center because it's written first, and hydrogens always have to be on the outside, I'm going to surround it symmetrically, and then I'm going to single bond it. And if I look at this, my hydrogens are actually happy because even though they have only 2, they are an exception and they want a reduced octet. So all my hydrogens are happy, so I don't need to worry about filling in extra lines around them to make them have an octet. My nitrogen has 8, so therefore it is happy. So what I'm going to do is put brackets around it and give it its charge of the +1. All right, hopefully you kind of have an understanding about a reduced octet, expanded octet, and if you have a positive or negative charge, what to do with them. Have a great evening.